Question number 33 says, integrate from 1 to 4, modulus x minus 1, modulus x minus 2, modulus x minus 3, and modulus are not difficult at all. By the way, in the next chapter, that is area under the curve, you will see, that is application of integrals, you will see that integrating these modulus is very easy with the concept of area, right? Modulus of x minus 1 area and between 1 to 4 is simple to calculate, right? But here, since we want to integrate using basic ideas of definite integration, we'll have to break this modulus around the critical points, break these integrals around the critical points. Yes, this is integral 1 to 4 modulus of x minus 1 dx. For this, the critical point is 1. This will be the only term that will be obtained from here. Plus, for this, you'll have integral from 1 to 2 modulus of x minus 2. Yes, modulus of x minus 2 dx plus integral from 2 to 4 modulus of x minus 2 dx. So what I'm doing is I'm taking these three terms separately and then finding this integral separately. This integral will be broken down into two parts. This will be again broken down into two parts. Another idea could have been that for this complete sum, you take three critical points, that is 1, 2 and 3. Okay, 1 is not to be worried about, but you break from 1 to 2, you break from 2 to 3 and you break from 3 to 4 for this complete expression. After that, you simplify and then you integrate. Okay. And that also you'll get similar kind of from, yes. What next? Plus, for modulus x minus 3, I'll integrate from 1 to 3 first, modulus of x minus 3 dx plus integral from 3 to 4 modulus of x minus 3 dx. And now, what do I observe? In this interval, it will be positive. This here in the interval 1 to 2 will be negative. This here will be positive. Between 1 to 3, this will be negative and this will open with a positive sign. Those are the important things to observe first of all. Once you observe that, can you integrate as well directly? Yes. So the integral of x is x square by 2. The integral of minus 1 is x from limits 1 to 4 plus. This will open with a minus sign, that is 2 minus x. So the integral will be 2x minus x square by 2 from 1 to 2 plus. This will open with a plus sign. This is x minus 2, which will be integrated to x square by 2 minus 2x from 2 to 4 plus. The next term, x minus 3 will open with a minus, that will make it 3 minus x. The integral will be 3x minus x square by 2 from 1 to 3 plus. This will open with a plus sign. The integral will be x square by 2 minus 3x from 3 to 4. So if you observe this question carefully, the only thing is, it is a long question in terms of calculations. Otherwise, these steps are very simple. Each and every simple step is very simple, right? What does this simplify into now? This is 4 square 16 by 2 8 minus 4 minus of 1 by 2 minus 1, which is minus 1 by 2 plus. What does this simplify into? 2 into 2 4 minus 4 by 2, which is 2 minus 2 minus 1 by 2, which is 3 by 2. This is what you get. Is that okay? Yes, please observe. 2 minus 1 by 2, we have substituted this plus. What does this simplify into? 16 by 2, 4 times 4 is 16 by 2, 8 minus 4 times 2 is 8, that will be 0, minus substitute 2. This is 4 by 2, 2 minus 4. 2 minus 4 will be minus 2 over here. Plus this term, let's take a look at this term. This is 9 minus 9 by 2, which is 9 by 2, minus 3 minus 1 by 2, which is 5 by 2, plus this becomes 4 square is 16 by 2 is 8 minus 12. 8 minus 12 will be minus 4. And this becomes 3 square 9 by 2 minus 9. 9 by 2 minus 9. There's a minus and this will be minus 9 by 2. Yes. Now what will this whole expression simplify into? Let's take a look at that. So first, let's simplify these terms. First of all, this is 4 plus 1 by 2 plus 2 minus 3 by 2. Can I write it as 1 by 2? Yes. 2 minus 3 by 2. This is 1 by 2. This is plus 2. That 9 minus 5 will be 4 by 2 will be again 2. Then you have minus 4 and plus 9 by 2. Yes. This is what you have. So what does this simplify into? This 4 goes away with this 4. That's the first thing that you observe. Then you have 2 plus 2, 4 plus 1, 5. 5 plus 9 by 2 is what I have. What is this 5 plus 9 by 2 equal to? This is 5 2s are 10 plus 9, 19 by 2. That is my correct answer for this 13th question, as you can see over here in this question. Now another approach, as I just mentioned in the beginning, could be to use the idea of applications of definite integrals, that is area under the curve. And if you have some idea about application of definite integrals, I'll explain this same question using that other approach, how simple it will be, right? If you don't have any idea about applications of definite integrals, you can maybe skip on to the next question. But then if you have a fair amount of idea, then let's talk about that area under the curve idea. This is x, this is y. Okay, for this particular function, I'll try to draw the graph of first this. So this is modulus x minus 1, modulus x minus 2, modulus x minus 3. You see x is throughout in power 1. So the graph between any two critical points will be a linear function, right? The critical points from 1 to 4 will be 1, 2, 3 and the end point is 4. So I'll find values for 1, 2, 3 and 4 over here. This is called 1, 2, 3, 4, 5, 6, 7. Maybe let's mark this 2, 4, 6 over here. On the y-axis, let's mark these points. For 1, this function becomes 0 plus 1 plus 2. For 1, the value is 3. 1 plus 2 is 3. This is 3, right? This point is 3. For 2, this becomes 0, this becomes 1 and 1, this becomes 2. So the value will be 2 over here. For 3, this becomes 0, this becomes 1 and 2, 3. So for 3, the value will be 3 again over here. For 4, the value will be 1, 2 and 3, which is 6. For 4, the value will be 6 over here. So the graph between these points will be this, of this shape, and the area under the graph will be this area between these points as written over here. This area, and then this area. Okay, this here is a trapezium. This and this are parallel sides and distance between them is this, right? So I can find the area very easily. Half sum of parallel sides, distance between them. Again a trapezium, half sum of parallel sides, distance between them. Again a trapezium, half sum of parallel sides, distance between them. If you see half, distance between each of them is 1. Yes. What about sum of parallel sides? Can I take sum of parallel sides 3 plus 2, 5 for this? Sum of parallel sides 2 plus 3, 5 for this. This is 3 and this is 6. Sum of parallel sides 9 for this. What is this equal to? This is 19 by 2. Oh, that was pretty simple. Once you draw the graph, calculations become very simple, much simpler as compared to this whole calculation of definite integral. Yes, so this is application of definite integral. We obviously get the same answer for this question as you can see over here. Right, that's the complete solution, and further analysis of this question, we'll move on to the next question after this.